All right, hello everyone. So today we have a calculus 2 question, approximate the integral that goes from 0 to 0.3 ln of the quantity 1 plus x squared dx to an 10 to the negative 4, round to 4 decimal places. Okay, so often it is the case when you're trying to approximate an integral of a function that you can't find the integral of like directly. We use series here. That's what we're focusing on today. And the first thing I want to do is try to work with a known series for my integrand, so get a series for ln of 1 plus x squared. So I know that 1 over 1 plus x is equal to going from 0 to infinity minus 1 to the k, x to the k. And that's got a radius of convergence of 1, which will stay throughout the problem here. Now, if I want to get a series for ln going, I can integrate 1 over 1 plus x. That'd be ln of 1 plus x. And essentially that would mean integrating our series here. And when you integrate the series, you basically concentrate on x to the k here, or it's integration by term. And this gets you to this point right here. Now, much of the time, the series for ln of 1 plus x is written with the index of 1. You can use any index you want here, that's up to you. But I'm going to go with the usual way with just k equals 1, as you can see, and these are equivalent here. And I'd pause the video just to see why, but one thing you can do to transform one to the other is replace the k's in red here with k minus 1. Okay, and I'll let you see how that works. And yeah, that would work out nicely. Anyways, I'm going to use that series to work with I'm going to use the series minus 1 to the k plus 1 x to the k over k. And I'm going to replace that x with x squared, and you get what you see here. Okay, and we're going to take, that's my series expression for ln of 1 plus x squared. I'm going to integrate that, and we get what you see here. I integrated x to the 2k. You got x to the 2k plus 1 over 2k plus 1. So again, using the power rule from integration, and all of that also divided by k, because you have that k in there, that doesn't go away. And then you're going from 0 to 0.3. So I'd put 0.3 in for x, and then 0 for x, subtract. And when you plug 0, that goes away. So this is the final answer for that integral in terms of a series. It goes from 1 to infinity minus 1 to the k plus 1, 0.3 to the 2k plus 1 over 2k plus 1 over k. Again, you could have started your index at 0, you come out with a different expression, but they would have summed the same thing. They're equivalent. Okay, so we can't actually figure out what that sum is. That's really impossible to do in this case to get an exact answer. However, what we can do is this. We can use the alternating series bound, which looks something like this, or it would be very hard that way to find the sum of that series. Actually, you can do it, but it would be difficult with like integration by parts. But using the alternating series bound, it's written here. You have the absolute value of your sum minus a partial sum. That's what S sub k stands for, is less than ak plus 1. And ak here basically is the sequence that's next to the alternating part, which is 0.3 to the 2k plus 1, all divided by 2k plus 1 over k. Ak plus 1 is basically me replacing all the k's with k plus 1. Now, you don't actually have to make this move, but I just find it a little easier to kind of follow along with those steps. Now, your goal would have been this. You would have tried to see when this expression, 0.3 to the k plus 3, divided by 2k plus 3 over k plus 1, is less than 10 to the negative 4. The best way to do that, and the easiest way to do that, is just by plugging a value of k in, for which makes it do that. So in this case, if you pick k equals 2, you would get, you would plug 2 into your formula, and you would get 0.000401014 here, okay? And that is less than the 10 negative 4. So that means that if you take the sum starting from, we went to 1, and all the way to 2, that value, that sum is going to be within 10 to the negative 4 of the actual sum. Now, and in fact, not just 2 works, but any number bigger than 2 would work as well. Okay, so it could be 3, 4, 5, whatever. And if you plug, and if you actually try to find the sum, the way that works is that you would go from your starting point to 1 to the value of k that worked for the area bound, which was 2, and you would have plugged 1 into this whole sequence, to the whole thing right here, and then 2, added those two numbers, and you get 0.008757, which is approximately equal to 0.0088 if you round it to 4 decimal places, okay? So that would be our answer. Now the exact value of 0 to 0.3 ln of 1 plus x squared is 0.008766689, and yeah, that's approximately. There's an exact value for this. But if you notice the two numbers, if you subtract them, they are within 10 to the negative 4 of each other, okay, those approximations. And that would be it. Thank you so much for your time. Hope this helps.